Alright, welcome to our first try at distance learning. We've got 5 problems here. 2 of them are just fill in the blank, 3 of them are long answer. I'll do 2 of them for you, and then you guys will do the third one on your own. Yeah. Now, this first one, Boyle's law, when blank is held constant, the pressure and volume of a gas are blank proportional. So, Boyle's law is P1 times V1 equals P2 times V2. The 3 variables that we're going to deal with in gas laws are pressure, temperature, and volume. Temperature isn't included in Boyle's law because it is the same. It doesn't matter what temperature we have, it would have no effect on this equation. So when temperature is held constant, the pressure and volume of a gas are blank proportional. This is the one where I told you if pressure goes up, volume is going to go down. Those are opposites, so the pressure and volume of a gas are inversely. Inverse means opposite. Inversely proportional. Now, mathematically, Boyle's law equals P times V, which equals P times V. That was kind of a silly one. Or P1 times V1 equals, I'm just going to take that right there, move that over to there. But I'm not going to rewrite it because lazy. Okay. Just basic multiple choice style questions that you guys might see. Now, my favorite, the math. Okay. At a pressure of 405 kPa, that's kilopascals, the volume of a gas is 6.00 cubic centimeters. Assuming the temperature remains constant, at what pressure will the new volume be 4.00 centimeters cubed? Now, just like we did since the beginning of the year, we're going to label all our variables. This is going to be Boyle's law. So we have P1, V1, P2, and V2. Now, if we look at this, how would we know that it's Boyle's law? Other than the fact that I told you that we're doing Boyle's law. Well, if you look at your problem, you have a pressure, a volume. You're looking for a new pressure, and I gave you a new volume. So the variables we're working with are pressure, volume, pressure, volume. The law that concerns pressure and volume is Boyle's law. Now, when we're just starting off this unit, I'll tell you which law we're using, but on your test, you know I love to give you one that's unknown, and you have to figure it out for me. Oof, it'll be fun. Let's fill in what we know, though. Pressure 1, we're starting off at 405 kPa. What's a kilopascal? Doesn't matter. You just have to know it's a unit of pressure. Volume 1, 6.00 centimeters cubed. Okay, now assuming the temperature remains constant, which means we can ignore that part. If it stays the same, it's boring and who cares. At what pressure? So it's saying what pressure? That's our question mark. That's the one we don't know. Will the new volume be 4.0 centimeters cubed? Now, before we do anything, we're going to make a guess. We know that the relationship between pressure and volume is inverse, so if one goes up, the other goes down. If we look at the volume we started with, volume 1, and we go to the volume we ended with, our volume has decreased. So our pressure is probably going to have to increase. So let's keep that in mind while we solve. Our guess is that P2 is going to be an increase over P1. Now, look at your formula. P1 times V1. P1 is 405. V1 is 6.00 equals P2 is unknown, so let's call that X, times V2, 4.00. Now, pull out our wonderful calculators. You can't see it, but I'm on my calculator right now. 2,430 equals 4.00x. Just divide both sides by 4.00. Divided by 4.00. 607.5. Great, we're done, right? Oh, no naked numbers. 607.5 is a number. We want to know a pressure. Now the unit of pressure we've been using is kPa. So we'll just move kPa over here. So our final answer, the new pressure, will be 607.5 kPa. Now let's check our original guess. Our guess was that pressure 2 would be an increase over pressure 1. Pressure 1 is 405. If pressure 2 is 607, is that an increase? I think so. So is this a pretty reasonable answer? Oh, definitely. All right, let's do number 4. A volume of gas at 1.10 atm was measured at 326 centimeters cubed. What will be the volume if the pressure is adjusted to 1.90 atm? Okay. Now, the wording on this one is a little weird. It says a volume of gas at 1.0 atm. Now, 1.0 atm is actually a unit of pressure, because here we have the volume at the end of the sentence. So this is just an English semantics thing. On things I give you, I'll word them more clearly. Good thing I'm doing this one for you. What will be the volume if the pressure is adjusted to 1.90 atm? Now, this problem has no mention of temperature, so it's probably Boyle's law. So we have P1, V1, P2, V2. Let's fill in what we know. So, again, it's worded badly, but 1.10 atm. ATM is atmospheres, which is a unit of pressure. It's the first one listed, so let's call that P1. 1.10 atm. Volume 1, the first volume, the one that's associated with this first pressure, is 326 centimeters cubed. Now it says, what will be the volume? So volume is our unknown. If the pressure is adjusted to 1.90 atm. Okay, let's rewrite our formula. P1 times V1 equals P2, oops, what am I thinking, times V2. P1, 1.10, times V1, 326, equals P2, 1.90, times V2, which is unknown, X. Now, we calculator. I get 358.6 equals 1.90x. Oh, I forgot our guess. So our pressure has increased, so our volume will probably decrease. So let's see if when we do the math we get a decrease. So we're going to divide both sides by 1.90. And that gives me 188.7, and then my unit for volume in this case was cubic centimeters. Now our guess was that volume would decrease. 188.7 is a decrease from 326. So is this a reasonable answer? Yay! Sure is. Okay. You guys solve number 5. Let's make this interesting. If you think you have it, post what the answer is in the comments. Oh, we'll see who gets it first.